Hello, everybody. It's awesome that you're here and ready for another week of learning. Today, we're going to be looking at this thing called the unit circle. And the unit circle, what it is it's the tool that has two purposes. The first purpose is it's going to help us better understand um, those trigonometric relationships between sine, cosine, and tangent. And the other reason that we're using the unit circle is that once we have a better understanding of those relationships, next week we'll start to use those relationships to make graphs of each of these functions. So that's where we're headed with this so the unit circle this week we're kind of playing around with, and in my experience, the unit circle is both kind of fun and a little bit frustrating. So prepare yourself for kind of two different emotions there as we get into it. So the first thing when we talk about the unit circle is that word unit, and that word unit references 1. It means that this circle has a radius of 1 unit, which is why if you look closely, it has that coordinate point 1, 0 written right next to it, because we're at the coordinate point 1, 0, it has a radius of 1. We can think of this as an x and y axis here. And notice that the degrees on this circle go in a counterclockwise direction. They go counterclockwise from 0 up to 30, up to 45, 60, and so on. And that breaks this up into quadrants. So this first quadrant, the positive x and the positive y, whoops, did not mean to zoom. We're going to call this quadrant 1. And then we're going to have quadrant 2 following, and we just keep going in a counterclockwise direction. Whoa, what happened to my radius there? I'll fix that in a second. And we have quadrant 3 in the lower left, and then in the lower right-hand corner, quadrant 4. So as we start to talk about the unit circle a little bit more in depth, we're going to be referencing those quadrants as well. So that's just something to keep in mind. So quadrant 1 is that upper right hand positive, positive, then it goes in a counterclockwise order. And so all the way around, we get 360 degrees, which is why it says 0 degrees or 360 degrees. And, this circle, we could actually keep going around and around and get 720 degrees and keep going. But today we're just going to worry about what's written here. So let's focus on this first quadrant for right now. And notice that it's broken up by these degrees. We have the coordinate point 1, 0. I got ahead of myself here. I actually don't want to focus on the first quadrant just yet. If we go up to 90 degrees, since this still has a radius of 1, right, this distance is 1, that would make this coordinate point 0, 1. We keep going counterclockwise over to 180 degrees. Now we are at -1, 0. And then at 270 degrees, now we're below, we're at 0, -1, and then back over to 360 degrees would get us back to the coordinate point 1, 0. So we're thinking of all of these, everything on the edge of the circle can be represented by a coordinate point. Now those 4 coordinate points are really easy to look at because, they're right there on the axes. It's these coordinate points in between, and now I'm going to focus on quadrant 1, that are a little bit trickier. But luckily we have some knowledge in our back pocket that we're going to get out and we're going to use here. So I'm going to focus just on this 30-degree line, and I'm going to create a right triangle. If I drop that straight down, I get a little right angle there. This interior angle in the lower left is 30 degrees, which makes this a 30, 60, 90 triangle. Now, we spent last week practicing 30, 60, 90 triangles and looking at those relationships so that we could use them today on the unit circle. Now, again, if this is a unit circle, it has a radius of 1. That means that this length of the hypotenuse is actually 1. And if I want to know this coordinate point that matches the edge of the circle there, well, I have to know the distance, the horizontal distance, and I have to know the vertical distance, which means I have to know those two sides there. So we're going to review how to use a 30, 60, 90 triangle to do this up over here. So our hypotenuse has a value of 1, right? Now, according to our relationships from last week, we can go back from the hypotenuse to the short side by dividing by 2, right? And that shows the relationship here. If I go from 2a to a, I'm dividing by 2. So 1 divided by 2, I'm going to write as 1/2. And last week we weren't super nitpicky. Some of us converted this to decimals. I'm going to insist now that we keep everything as a fraction. And then to get the length of the long leg, we take the length of the short leg and we multiply by square root 3. So in this case, if it's 1/2 times square root 3, we're going to get square root 3 over 2. I want to write this as an improper fraction, as just one ratio. So that means I can compare these side lengths here, right? This is a height of 1/2. This is a length of square root 3 over 2, which gives me these coordinate points. My x distance is my x coordinate point, square root 3 over 2, and my y value is my vertical height, 1/2. And so that's the coordinate point I get right here. Now, how does this help us, right? Really what this makes it seem is like, oh no, I have to do this for how many of these? Well, we'll get to that in just a minute. But I want to provide another visual of what we just did here. So we zooming in on this unit circle a bit. Again, we have a radius of 1, right? This length is 1. And so what we just did was we made this coordinate point. It's got it written in the fraction form. It's kind of in the light green, a little bit hidden. How this helps us is this is what's called a reference angle. On the other side of the y-axis, we could think of another 30-degree angle and make another triangle. That triangle would have the same hypotenuse, right? A hypotenuse of 1, and it would have the same long leg and short leg. If the long leg has a distance of square root 3 over 2, we're going square root 3 over 2 units in the negative direction and 1/2 unit vertically. We could also do the same thing over the x-axis. We could think of having these little 30-degree reference angles along the way. So the unit circle makes this really consistent pattern for us that we're going to start to develop here. Oops, and this should say square root 3 over 2. Why didn't you guys tell me? So if that was a little bit too fast, you're like, I did not catch that at all, Miss Womble. Just take a look at my picture here. So again, I've got the same 30 degrees. I've got the same hypotenuse. And what you remember from triangle similarity in geometry is that if I have the same sides and the same angles, right, I'll have the same triangles. So this triangle over here also has a height of 1/2, and it also has a long leg length of square root 3 over 2. That was the weirdest 3 I could have done. And so if I put this in the negative direction, well, my x distance is negative square root 3 over 2, and my y distance is a positive 1/2. So the challenge here would be to continue to label these coordinate points based on that particular reference angle. Of course, this is not the only reference angle that we have. So let's take a look at what else we have going on here. I'm going to use a different color here to take a look at this 45-degree angle. And again, I'm going to draw in my triangle, my right triangle. And that right triangle represents the length of the legs there. Since this is a unit circle, my radius is 1. And now I have to figure out what's the vertical and the horizontal distance covered to go from the origin to the outside of the circle. Well, luckily we reviewed our 45, 45, 90 last week as well. So this relationship here says that if I have a hypotenuse of 1, which I do, I'm going to find the length of the legs by dividing by square root 2. And so what we actually get is we get something that looks like this, 1 divided by square root 2. But if you remember from our radicals unit, we're not allowed to leave a radical in the denominator. So we need to do just a little bit of algebra here to get that radical out of the denominator simply by multiplying by, a fancy 1. Square root 2 divided by square root 2 is equal to 1. We're not changing the value, we're just changing the way it looks. So we get square root 2, 1 times square root 2 is square root 2, divided by the square root of 4, which is just 2. So while it would certainly be easier to write it as 1 divided by square root 2, we're going to write it as root 2 over 2 because that is our convention. I didn't make the rules, people, you know that. We just have to follow them. If we know the length of one leg, we know the length of the other in a 45, 45, 90. So that puts us in a good spot. That means that this horizontal distance is square root 2 over 2. The vertical distance is square root 2 over 2. And that means that this coordinate point is also square root 2 over 2 for both the x and the y values. And again, if we think about what happens here, perhaps I will use a different angle here. Below, on another 45-degree angle between the x-axis and this 315-degree, right? If we go backwards from 360 by 45 degrees, we get another 315 degrees. So if this angle here is 45 degrees, then that means we have the same leg lengths. We have square root 2 over 2 for the horizontal, and we have square root 2 over 2 for the vertical, but this time it's going down. So our x value is still square root 2 over 2, but our y value is going to be negative square root 2 over 2 because it's going in the negative y direction. So one more reference angle in this quadrant, and let's see what color I can use. I don't prefer it. I'm going to use orange because it's just a little bit different than the other colors. So don't blame me if this color's ugly. Sorry, letting my personal feelings get in the way of the math. Never again. All right. So this time I've got a 60-degree angle, right? And another 30-degree angle here, and a hypotenuse of 1. But as it turns out, we've actually calculated the length of those legs, right? Just because the triangle is oriented a little bit differently, right? This one time it's got the 60-degree and then the 30. That's okay. Just because we oriented it a little bit differently doesn't mean that the legs are a different length. So we've actually already done this work. We're just flipping it around a little bit. So we've got a vertical height of square root 3 over 2 and a horizontal distance of 1/2, which means that my coordinate points, horizontal, the x value is 1/2. My y value, my vertical, is root 3 over 2. So the challenge that I am posing to you now is to try to fill in the rest of the coordinate points around this circle using just these 3 angles as a reference. And I've done a couple of them for you. I guess I'll do one more over here at 120 degrees. Again, if we go from that horizontal, that's the key here. So we're going from the horizontal axis. We have 60 degrees here. We have a right angle and we have a little 30 here. So we know that our horizontal length is 1/2, but we're going in the negative direction. So we have negative 1/2 as our x value. And then in the positive, in the vertical direction, we have a positive square root 3 over 2. So that's our y coordinate. So again, my challenge to you is to fill in the rest of the coordinate points around this circle using those reference angles and the right triangles. And I would try to color coordinate these. If you can pick a better 3 colors than me, more power to you. But see what you can get done. And then you can always check your answers with the key that I put in the content library. From here, we're going to talk a little bit more about how to use the unit circle, but for right now, let's just get that visualization, get that tool ready to use. All right, great job, guys, and I will catch you on the next video.